All right, guys, good morning. So I cannot get the document camera to work like I anticipated, so I'm going to have to get somebody from school to help me work through those kinks today. But for now, we're going to work on this pretest. So be sure, if you have not done so, you read this important information right here. It's going to kind of tell me what you know and what you don't know. Okay? All right, so we are going to go ahead and get started. So on numbers 1 through 4, we are just simplifying fractions. All right, so when we're doing fractions, especially when we're adding and subtracting, we have to have a common denominator, which means the bottom number on your fraction has to be the same. So remember, the numerator is on the top and your denominator is on the bottom. So on number 1, we have 1/2 plus a 4th. Well, if you notice, these two numbers are not the same, but we want to get them to be the same. So, is there a number that I can multiply with 2 to get 4? Think in your head. Yes, we can multiply by 2, right? So I'm going to multiply this whole left side by 2. But once I do it on the bottom, the rule is I also have to do it on the top, right? So now we have a new fraction. So 1 times 2 is 2. 2 times 2 is 4. We're going to bring down what we did not use. Now that these are the same, we can add straight across, right? So 2 plus 1 is 3. And then you keep your denominator. All right, on number 2, we have 3/4 minus 1/3. Well, those are not the same. So think of it this way. Is there a number that I can multiply with 4 to get 3? Well, no, because 3 is less than 4, so we can't do that. So let's try the opposite way. Can I take a number and multiply it with 3 to get 4? Well, no, that doesn't work either. So we have to find a common term that we can multiply by and get the same number. So think of your multiples of 4 and 3. So 4, we have 4, 8, 12, 16, and so on. 3, we have 3, 6, 9, 12, 15, and so on. Do you see a common number? Yes, 12. So we can say 4 times 3 is 12. And we can say 3 times 4 is 12. But we know that whatever we do on the bottom, we must do on the top. So then we simplify. We're getting 2 new fractions. 3 times 3 is 9. 3 times 4 is 12. Bring down our subtraction sign. 1 times 4 is 4. 3 times 4 is 12. Now that we have a common denominator, we can subtract the top. 9 minus 4 is 5. All right, next, number 3, we have 1/3 times 1/2, and you'll notice that it's multiplying. So I want you to jot down, multiply straight across. So 1 times 1 is 1. 3 times 2 is 6. And that's my answer. All right, number 4 is a division. And I know some of you have had Miss Gorley in middle school. Well, Miss Gorley taught me in 6th grade at Alamo, and she taught me this, and I will never forget it, the way she taught it. So when you're dividing fractions, it's not KFC the chicken, it's KCF. So that stands for keep, change, flip. So we are going to keep our first fraction. We are going to change our sign. So the opposite of dividing is multiplying. Then we're going to flip our fraction. So instead of it being 1 over 2, it's going to be 2 over 1. Now we have a multiplication problem, which we just learned that you multiply straight across. So 1 times 2 is 2. 6 times 1 is 6. So now we have 2 over 6. But I'm pretty sure that I can simplify this because 2 and 6 are both even numbers. So, how many times does 2 go into 2? 1. How many times does 2 go into 6? Well, 2, 4, 6. 3. So my answer here is 1/3. All right, next on numbers 5 through 12, we are doing order of operations, which we touched some on yesterday. So go ahead and write, please excuse my dear Aunt Sally. All right, some of these are really easy, some of these can be a little tricky. So number 5, -1 minus 6. Well, I think of it like this. If my bank account is negative, I'm in the red. I don't even have $0. Like, I'm already broke. So I'm already missing -1. I've already spent too much. And I spend another 6 more that I don't have. Well, now I am -$7 in the hole. Number 6. Yeah, number 6. So we have 2 minus -3. Well, I told you yesterday this is going to be an important thing to remember. But what do 2 negatives make? 2 negatives beside each other make a positive, right? So now we just have 2 plus 3, which is 5. Kind of the same thing with number 7. When we are multiplying or dividing, that same rule applies. So when you're multiplying 2 negatives, your number is going to turn out positive. Or when you're dividing 2 negatives, your number is going to turn out positive. So right here, these 2 negatives make a positive, right? So we have 7 times 3. Or -7 times -3, we're both going to get 21. Now, number 8 is different because only one of those is negative. So if just one of your numbers is negative, you just keep a negative sign. So -4 times 5 is -20. Okay? Now, 9 through 12 are a little bit harder. So number 9 says 1 minus 5 squared plus -2. So our order of operations tells us to do parentheses first. So we're going to simplify. So 1 minus 5 is -4. And we're going to bring down everything that we have not used. All right, then it says to use our exponents. Well, what does this right here actually mean? Negative 4 times negative 4. Now, if you go back to check with your calculator and you don't use those parentheses, you're going to get a wrong answer. So parentheses are very important to use when you are using your calculator. Okay? So, negative 4 squared. This is what this right here means. Negative 4 written 2 times. So we know that is a positive 16. Let's bring down everything we have not used. Remember from yesterday, a negative trumps a positive. So we have 16 minus 2, which is 14. All right. Next, number 10. We have 2 times 8, or negative 8, plus 2 divided by negative 2. All right, so remember we have to do parentheses first. So we're bringing down our 2 we have not used. Negative 8 plus 2 is a negative 6. Bringing down what we have not used yet. Now, notice, we have both multiplying and dividing at the same time. But remember, I told you yesterday, you always work left to right in a case like that. So, starting with the left, 2 times negative 6 is negative 12. Bring down what we have not used. Now, notice that both of these numbers are negative. When you're dividing two negatives, your answer turns out to be positive. So negative 12 divided by negative 2 is positive 6. All right, next we have the distributive property. The distributive property is you take your number on the outside and you multiply with everything on the inside. Okay, so number 11. 2 times x plus 3. My 10th graders that I taught last year like to call the distributive property the rainbow method because we make a rainbow, okay, with each term. So, 2 times x, 2x. 2 times 3, 6. Now, I can't go any further because those are not the same type of terms. We cannot combine like terms because we have nothing to combine. So that would be our answer for number 11. Now, number 12, we have 3 times x plus 3y plus 4z. We're going to do the rainbow method 3 times because we have 3 terms on the inside. 3 times x, 3x. 3 times 3y. So we say 3 times 3 first, which is 9. And then drop down our y. Same thing with 4z. 3 times 4 is 12. Bring down your z. We do not have common terms. They all have different numbers. They all have different letters, so we cannot combine them. All right, next, number 13, 14, and 15. This is kind of similar to what we did yesterday. We're plugging in numbers for the expressions. So we are told that x equals 3 and y equals negative 3. So for the first one, we just have x plus y. So we're just plugging in 3 plus negative 3. Well, remember, negative trumps a positive, so this equals a big fat 0. And number 14, we've got to do a little bit more. So anytime you plug in numbers, let's always use parentheses, okay? So we have 4y plus 2x. So there should be 2 sets of parentheses on this problem on your paper. 4 times negative 3 plus 2 times positive 3. 4 times negative 3 is negative 12 plus 2 times 3, which is 6. Then we just simplify. Negative 12 plus 6 is a negative 6. Okay. Number 15, we have 2 times 3x plus 2y. Now you'll notice that the letters are within a parentheses already, but guess what? You still have to put more parentheses. So, 2, 3, parentheses, just like that. They have to do order of operations here, so we're going to simplify our parentheses first, right? So, 3 times 3 is 9. Bring down our addition sign. 2 times negative 3 is negative 6. Simplify this again. 2 times, well, remember, negative trumps the positive. 9 minus 6 is 3. 2 times 3 is 6. Now, if y'all need to, Miss Wendy can always pause this so you have time to write this down and to go back over it in your head if you need to. Or, it's going to be on Teams. You can always watch it later at your own pace and jot this stuff down if you need to. Don't forget that. All right, next we are going to solve some equations, okay? So, excuse me. So we're going to start with number 16. Number 16 is a one-step equation. So above where it says solve for x, I want you to write the words get x by itself. Okay. Now, I'm not sure how you've been taught to show that you're solving an equation, but I like to draw a line straight down where my equal sign is every time. So, like on number 16, we have x plus 2 equals 5. Well, if I'm going to solve that equation, first thing I'm going to do is I am going to draw a line just like this so I can separate my sides, okay? Now, we have to get x by itself. Well, you notice that x has a plus 2 attached. So we have to get rid of it. By getting rid of something, you have to do the opposite operation. So what is the opposite of adding? Right, subtracting. So we're going to subtract 2. Now, remember, the rule is whatever you do to one side of the equation, you have to do to the other. Now, it's going to cancel out, right? 2 minus 2 is 0. So that just leaves us with x equals, bring down your equal sign, 5 minus 2, which is 3. Now, you should be able to plug that back in and you get the right answer. So if we plug that back in, is 3 plus 2 5? Yes, so that is correct, right? All right, number 17. Two x minus 3 equals 7. And this is going to be a two-step equation. So, we've drawn our line. We have to get rid of our constant numbers first. They've got to all be together. So, let's move this -3, because remember we're trying to get x by itself. So the opposite of subtracting is adding, so we're going to add 3 to both sides. These are going to cancel, and we're left with 2x equals 10. But I still don't have x by itself. Right now, x has a 2 directly attached to it. 2 and x are multiplying. The opposite of multiplying is dividing. Whatever you do to one side, you do to the other. These 2's cancel, and you're just left. You are only left with that x. Notice there's nothing crossing that x out, just the 2's. So x equals, what is 10 divided by 2? 5. Good. All right, number 18. (3x minus 2 equals 4x plus 1. This was a little bit trickier, okay? So, we are circling our like terms, our x's, and we are boxing our constants. We got to get the boxes together. We got to get the circles together, okay? So, I'm choosing, it doesn't matter which way you work the problem, but I am choosing to do it this way. These cancel. And I'm going to do the other way, this side. These cancel. So, -2 minus 1 is a -3. 4x minus 3x is a 1x. Notice the x is not by itself just yet. There's still a 1. So, what do we have to do? Right, divide by 1. The 1's cancel. You're just left with your x. X equals -3 divided by 1 is a -3. Alright, so if you notice that my handwriting just got a little sloppy, it's because my pen just died and my charger is in my desk at school, I think. So, bear with me. So, number 19. 3x plus 2 plus 2x equals -4. Okay, we have to do order of operations first, okay? 3 times x, 3 times 2. Bring down everything we haven't used. Now, we have 2 like terms that we can combine on the left side. 3x and 2x, which leaves us with 5x plus 6 equals -4. So all I did was combine 3 and 2. Okay, now we have a 2-step equation. Drawing my line. Got to get that 6 over with that 4, right? So we're subtracting it. Those are canceling. We're bringing down the 5x. -4 minus 6 is -10. Alright, now I'm going to have to erase this so we can move to the top. We've got 5x equals -10. Well, notice that 5 and x are right together. So they're multiplying. The opposite of multiplying is dividing. So x equals -2. All right. Number 20 and 21. You have probably done this, but it might have been towards the end of 8th grade. You may not have got to spend a lot of time on it. So we are going to learn all of this again. Keep that in mind, but we are just pre-testing to see what we remember. Okay. So find the slope. So slope, remember, is rise over run. Slope between 2 points. y2 minus y1 over x2 minus x1. All right, so x1, y1, x2, y2. Okay? So you just plug those numbers in. 6 minus 5. 6 minus 2. 6 minus 5 is 1. 6 minus 2 is 4, so my slope is 1/4. Okay? Coordinate points. X comes first, Y comes second. Remember the alphabet. X comes first before Y. Okay? On number 21, we do the same thing. In this case, we still have x1 and y1. We have x2 and y2. So like I just did, we're just going to plug those numbers in. So y2 in this case is -3 minus, because that's what our formula says, our y1, which is 7, divided by x2, which it tells us is -4, minus, and x1 is a -2. Now, just because x2 is negative does not mean that you cannot put your subtraction sign, okay? You have to include both. And we'll talk more about that later. -3 minus 7 is -10. Oop, two negatives, they make a positive. So -4 plus 2 is -2. Oh, two more negatives, so they're going to make a positive. So -10 divided by -2 is +5. Okay? All right. Write an equation in slope-intercept form. Slope-intercept form, y equals mx plus b. M is my slope. B is my y-intercept. Right? So, on number 22, it tells us the slope is 2 and the y-intercept is 3. So, you just plug it in. You have no solving. Y equals mx. Well, the slope, if the slope is m, then it's going to say 2x. My y-intercept is a +3, so you're just going to attach a +3. Gets no harder. On number 23, it says the slope is -1. Y equals -1x. My y-intercept is -5, so instead of having +5, it's going to say -5. Now, you could also write it as y equals -x minus 5. Okay? Those are the same thing. If your slope is 1, you really don't have to put that 1 because it's kind of understood, right? All right. Now, let's look at these graphs. Let's see if I can do this without a pen. So, when you are graphing an equation, you always start at your y-intercept. So, looking at your equation on number 24, is 2 or 1 your y-intercept? 1. And it's a y-intercept because it starts on the y. So I'm going to put a point right here on the 1. Now, my slope is 2. Remember what we wrote a minute ago? Slope is rise over run. So I am rising 2 times and I'm running 1 time. Since it's positive, we're going up and to the right. So put your pencil on your 1, that your y-intercept, count up 1, 2. Well, over 1. 1, 2. I'm having some trouble here. Over 1. Rise 2, run 1. Now your line don't have to be perfect. Now that line is increasing, which means it has a positive slope of 2. All right, number 25. All right, what is our y-intercept? Think in your head. 2 seconds. 1, 2. You got it? Put it on your paper. Did you pick -1? If so, good job. All right, now our slope here is 2 over 3, so that means we go rise 1, 2 over 1, 2, 3. Rise 1, 2. Run 1, 2, 3. Connect my dots. And there is my positive line. So, I hope you had a little refresher as we did this. I will have you something for tomorrow in class that I hope you will enjoy. It involves working with the calculator. I'm not sure how if y'all have ever worked with these types of calculators, but it's a scavenger hunt, so you're going to have the opportunity to work around. You can work in groups if you want, and then towards the end of class, I'm going to hop on our Teams call, and we will go over it to make sure we are learning how to use our calculator. So I hope you all have a great day and you are staying healthy. See y'all later.